Hello everyone. Today I'm going to tackle some very important concepts in operating systems and computer architecture, namely virtual memory, translation lookaside buffers, multi-level page tables, and I'm going to use a fun little anecdote to explain all of these rather complex concepts. This is something which I experienced as I sat a lot of public PhD defenses. They always begin their thesis presentation with anecdotes so that the non-academic participants of the audience get a foundation to listen to the rest of the thesis presentation, and the people from the academic backgrounds get to deepen their understanding of those concepts through developing a sort of intuition for them. And that is what I hope to impart to all of you on this journey. I will be creating a lot of these anecdotal concept representational videos in the series, and I'm going to start with this one. So let's dive right into it. We will also see how this anecdote relate to the actual physical components of computer architecture as the video progresses. So let's begin. So our story starts with Ron. Ron is a pretty smart, ambitious young librarian. He has just opened his first library, and let's ignore all of these parts. It's only this much, as we can see. This is Ron's library, which he has opened up, and he is very motivated. He has remembered the location of every book in his library. He knows it by index. So whenever any customer comes to Ron and he's like, I want a certain book, Ron knows it's over here. He will pick that book up and he will give it to his customer. And in that way, Ron has been servicing the requests which come to him. As his store gets more popular, he starts expanding his library. And the time comes when Ron is not able to remember the location of every book in his library. So what is happening is that Ron is spending a lot of time searching for the books in his library, as he does not know the exact physical location of each book anymore. And this is causing dissatisfaction among his customers. Ron, being a smart individual, he takes a particular index, let's name it A5, and he places a book over there which indexes all of the other books in his library. When he opens up this book, he can look at the location of every other book in his library and he can start servicing requests. So whenever any customer comes, Ron goes up to this book and he fetches it out. After fetching out the book, he opens the book and then he looks at it. Let's say the customer had asked for Mars series the second or Mars series the third for this example. So he sees, okay, in the book, he has mentioned Mars series is at the shelf E at the location 7. From here, the Mars series begins. And because the customer has asked the third book, it is going to be at the third location from E7. So he reaches E7 and then 1, 2, 3. And there he can find the book. That is because Ron is smart. When arranging the books, he has done it sequentially, making indexing easier. With this, Ron starts servicing the requests of his customers. And let's say this is E7 the third. So it's like E7, 1, 2, 3. He has reached over here. So he takes that book, he goes back to the customer and he gives back Mars the third. And that starts going pretty well as well. Now Ron does not have to remember the location of every book in his library. He just needs to make sure that this one book, which is at A5, which he calls the page table, or what we call the page table, he calls the indexing book, remains updated. So whenever he brings a book into his library, he updates the page table. Every time he brings in a new book, he places it at E7 or EZ55-3. He updates the book with that location. But now there is a problem. As the number of books are growing in his library, the thickness of the indexing book is increasing. And the time it is taking for him to turn the pages and look for that exact book in his own indexing book has reached to such a bad level that the people showing up are again dissatisfied. Ron thinks up an ingenious solution for this. He says that the problem is the lookup. Every time he has to look up into the book, it is very thick. So he needs to find a way to look at a certain subsection of it. So what he does is, very smartly, he updates the book as indexing other index books in his library. These other index books can be placed anywhere because he will store the location of these books in his main index book. So the entire library space is now divided into these sub-index books. These sub-index books only index a certain part of the library. For example, this index book might only index a certain shelf or a certain genre. So in that way, between all of these different index books, he is indexing the entire library. And these different index books are all indexed by the main index book. In this manner, each book's thickness, instead of one big book like this, he has a lot of small books like this. And let's say he finds a particular index book. This has, let's say, a certain book which he wants to look for. For example, Hyundai series, right? Hyundai the third. He needs to service it. Now, instead of going through this thick book, which includes all of the different books, he'll just go through the main book. He'll go to the book which indexes Hyundai series. That Hyundai series book will then point him to an exact location in the library. So let's see how he would do it. So first, he will go back to his trusty main index book, which is at A5. He calls this page table level 1, or he calls it main indexing book. It is at, let's say, A5 or A3, whatever is the case. He knows where this book is, and he opens it up. And this book basically indexes the different books. So AUN is a book. So all of the books starting with AUN must be in this indexing book. And all of the books starting with HUN will be in this indexing book. So now Hyundai series has been asked. So he's going to look at HUN. So HUN is at D12. All right. So D12 is, let's say, this one. So he goes to D12 location and he pulls out that book. Now we call this page table level 2 in computer architecture. He will be calling it a sub-index book. He will open it up and he looks at this. Okay, Hyundai series is at S99. Now this is good. Hyundai series is at X99. Now he needs to service this request. He knows that he's looking for Hyundai series the third. So it will be, he will go to S99, then 1, 2, third. He's going to service this book. So he's going to take out this book. He's going to bring it to the customer and he's going to service that request. All right. So I think that was pretty simple for Ron. Now he just needs to go to his first book. Then he needs to go to his second sub-index book. In his sub-index book, he's going to find the physical location of that book and the offset. So for saving space, he does not index each book. He indexes a series. So Hyundai series is at S99, Honza series is at Q5. And then whatever is the index of the book, like for example, Hyundai book number 1, 2, 3, 4, he will use it as an offset, and the same as the part number of the book, he will jump that many blocks or that many books from S99. That way he stores more than one book in every line of his sub-index book, or what we call as page table level 2. Right? Now this has been pretty fun. But now the problem is success. Ron has been so successful that he gets customers from all around the world, and they ask for books in different languages. They ask for books from obscure authors, and no matter how much he has expanded his library, it's already full. He has used up all of the space which was there in his main library. But Ron, again, being a smart businessman, he purchases the warehouse across the highway, which was empty. Empty land, cheap land, barren land. It had no sort of infrastructure, just a shed. So Ron bought it and he converted it into this huge warehouse of books. Right? And now what he does is, in his sub-index book, if the book is not in his main library, then he just says look for it in the warehouse. Whatever are the normally indexed warehouse books, he brings it into his main library so that next time he can service them quicker. So let's see an example of how that might happen. Let's say a customer comes to him, he says, please give me Hunger Games Part 2. Ron being Ron again, he first has his process set. He will go to his first book, page table level 1. He will look at his main index book. He'll be like, okay, Hunger Games starts with Hun. So we have to go to the sub-index book in D12. So he goes to D12 location. He picks up that book. He opens it up. He looks at Hunger Games series. Oh my God, it's in the warehouse. Now, he knows it is in the warehouse, but the warehouse is very big. And it's going to take some time for him to look it up. To begin with, Ron is going to have to walk from his main library, cross the highway, go into the warehouse, which is very huge. The main library might be, let's say, 2,000 square feet, but his warehouse is maybe 20,000 square feet. So he has to walk around all of the ways, and then he's going to find the Hunger Games book, and then he's going to bring it back to his main library, and he's going to bring it back to his main library, and he is going to give it an index, right? He's going to place it somewhere, and he's going to give it an index, let's say T49, right? And he's going to close his sub-index book. Now, Ron is going to go back to his first index book. He's going to restart the procedure. He's going to look at his first book, main index book. He's going to go to D12. Okay, keep it down. Maybe the entire warehouse movement was done by his colleague. He does not know that. Okay, now he opens up his page table level 2 or his sub-index book, and he looks at T49. Okay, now I can go to T49, and because he's asking for part 2, I'm going to go 2 indexes right. So this is T49, go 2 indexes to the right, T49, 2 indexes to the right, and he's going to find Hunger Games part 2, and he's going to give it to the customer. In this manner, he is going to service the request of the customer again. But you know what? Ron has realized one thing, that a lot of customers are starting to ask for the same books, and he does not want to always look up into the main index book and the sub-index book and then find the location and then service it, because he's reading 2 books, and that also he has to go into the library and search for them. So it has become tiresome. So you know what? Ron purchases a table, and he puts a very small book, Let's say if this book was 1,000 pages, this will be 3 pages or 2 pages, just like a sheet of very usually requested books by the customers, and he puts it on his table. Let's take the example of Hunger Games again. Let's say the person comes in and he asks for Hunger Games part 2. This time he looks up into the sheet which is on his desk, and he sees, okay, Hunger Games. Okay, I could not find Hunger Games in my sheet. So now what happens is, now that he cannot find Hunger Games into his sheet, he goes to his trusty old method. He goes back to his page table level 1, or what he calls as the main indexing book. Hunger Games as starts with Hun. He's going to go to the second book at D12. Second book at D12, he opens up, calls it the sub-index book. We call it page table level 2, Hunger Games series, T49 2. Alright, now what he does is, he goes back to his sheet on the table. And what he does is, he writes back Hunger Games 2, and he writes T49. He takes back T49 and he writes back over here, because he is indexing number 2, then it will be number 2. He writes back to the sheet, and then he closes it up. He opens it again. Now he looks, okay, I have Hunger Games part 2 request. Can I look at it in my sheet? Yes, it is in my sheet. So let's go to location number T49, number 2. He goes over there and he services that book. Now, the next time someone shows up at his table and asks him, can I please have Hunger Games Part 2? He does not have to go to the main index book. He will not go there first. He will first go to his trusty little sheet. And you see, okay, Hunger Games Part 2 is in T49, index 2. So he's going to go over there. He's going to look it up. He's going to give it back to him. Every time it is not in the sheet, he's going to go to the main index, to the sub-index, to the location. He's going to write it back into his sheet. Then using his sheet, he'll go to that location and he will bring it to the customer. That way, every time this sheet gets updated with the most recent purchases or the most commonly asked books, most times everyone is going to be asking for the same book. If it's Hunger Games Part 2, it's always going to be Hunger Games Part 2 because it's in trend right now. Now let's say this thing gets full. Let's say we have no more space left on the sheet. We have used up all of it. And we want to service a new book request, right? What is going to happen? Let's say a person asks for Hunk series, right? So what is going to happen is he's going to look at this. He's going to be like, okay, it's not, Hunk series is not over here. He's going to open up his trusty main index. He opens it up. He says Hunk starts with HUN. We have to go to D12. He goes to D12. He sees Hunk series is at Z1011. All right. Now he has that. He goes back to his sheet. But oh my God, we do not have any location left in our sheet. So what he does is he takes out the request which has not been used in a long time. Let's say no one has asked for Zatar Phi in like weeks. He's going to remove Zatar Phi. He's going to put Hunk series at Z1011. And let's say the person asks for Hunk series the third. So he's going to write third because that is the indexing he's using. And then wherever Z011 is, let's say Z011 is over here. He's going to go 1, 2, third. Okay, this is Hunk series part 3. He's going to take this book and he's going to service it. So in that way, whenever we are out of space, he's going to erase whatever is the last or the least used or the least recently asked book, and he's going to update that with the most recent series, right? In that way, this sheet always, even if it is full, it is able to service requests, but it has to evict whatever was the least recently used option. So with this, actually, we have learned how virtual memory works, with translation lookaside buffers work, and how multi-level page tables work. I'm going to take the next 5 minutes to explain that in depth. So let's take a look at one of our examples. Let's look at the Hyundai 3 example. What happened was that a person came in, he asked for Hyundai 3. Let's not look at the TLBs. Right now, we are just going to understand multi-level page table translations first. So we asked for Hyundai 3. So the computer first took the first part of the address, which we are looking up for. This, let's call this our address. Took the first part of it. Let's say Hun. He looked it up in its page table 1. First of all, where is page table 1? This entire thing is located in your RAM. So it goes into the RAM. It looks for Hun in your page table 1. We know the index of page table 1, and it sees, okay, this is referring to another page table. It goes to that page table. This page table is stored somewhere else in the RAM. And it looks at, it's not going to look at Hun. It's only going to be indexed by that, because all of the things in this page table are actually already prefixed with Hun. Now they are just looking at Hunk, Hyundai. So we are going to look up for Dai, the second part of our address. And we're going to find a physical location, which is S99. We're going to take that. We're going to put it in the first part of our physical address. And whatever is the second part, which was Hyundai 3. So we know that 3 is exactly, we have to go 3 locations ahead. So we are going to take 3 and we are going to update the physical address as the second part. So S99 3. This in totality is going to give the physical address of the data which we are looking for. The data is synonymous to the book in our example. This physical address will be stored somewhere in our RAM itself. So we are going to find this data at the location S993 in our RAM. Now what happens when it is not in our RAM? Let's say we had the situation where our Hunger Games 2 was in the warehouse. So this is our main index book. This is our sub-index book. So first we look for the first part of the address, which is Hun. We find that in page table 1. Again, this is all in the RAM. Then we find that it is referring to another page table. We go to page table number 2. And over here, we index it with the second part of our address, which is GUR Games. So we find GUR Games. Oh, it is indexing to the disk. This data is not on the RAM. So it goes to the disk. From the disk, it will find where our Hunger Games, this address is stored. It is going to bring it back into RAM. It is going to bring back that data into RAM. It is going to give it a physical address. Let's say it is T99. And it is going to update it over here. So instead of disk, we are going to have T99 written over here. We'll again start our cycle. We'll go look at Han, go to page table 2. We're going to look at GUR Games, T99. We're going to bring T99 over here. And 2 is our page offset. We're going to copy it straight off. And this is going to give us our physical address. This physical address is stored in our RAM itself when we broke it back from the disk, and we're going to look it up. We're going to find the data, and we're going to service the request of whoever asked it, whether it was a CPU or whether it was something else, peripheral. We're going to service that request. So this part is called page offset. Page offset is directly copied from the requesting address to our physical address. And this Hunger Games, it's called a virtual address. Our virtual address, as we translate it through our page tables, is converted into this thing called a physical address, right? And what we call this physical address is a physical page number. Why? Because we got this physical address from our page. So this is the page number. So we got that physical page number T99, and that is how we service this request, right? Now, we have already gotten this down. We start from main index 1, go to sub index, to our disk, to back to RAM, and in this way we are able to service requests. But as you can see, this is a very tedious process. So what did the person do? He introduced a TLB. A TLB basically is a direct mapping from virtual addresses to physical addresses. So once this has been stored in our disk, he's going to bring it back to over here, Hunger Games 2. Whatever was the entire virtual address asked, we are going to write it directly into our virtual address. And whatever was the physical address which we got, we are directly going to write it into our physical address, T992. So next time a CPU or someone asks, can you give me the physical address for virtual address Hunger Games 2? It is directly going to service to T992. We do not have to go through this entire translation. So this is a very fast methodology. And as you can see, the page table mechanism completely happened in RAM. So it was a software solution. We did not have to introduce any new hardware for it. But for our TLBs, we are introducing a completely different hardware, which is a TLB, Translation Lookaside Buffer. So this is some extra hardware which we're introducing into our system, which makes it a bit more fast. It accelerates our lookup times. And in that way, we are able to service requests a lot faster. So in this, we understood that our customer or our programs from on our CPU, they are not going to ask us for data directly by giving us the exact physical address. They do not care for the physical address. They are going to give us a virtual address. Almost like when we use our web browser, we do not write the IP address of Google. We just write google.com. And that google.com gets translated into an IP address, which we look up in the servers. In the same way, our programs are going to give us virtual addresses, which are not going to look like Hunger Games 2. They are also going to look something like bits. For example, a virtual address might look like 0x1285. And that is going to get translated into 0x7787543. So it is also going to look in bits because computers only talk in bits. So our program is also going to do that. But virtual addresses have certain benefits to them. And now that we know that our virtual addresses, in this case Hunger Games 2, can get translated to our bookshelves, which is our physical addresses in the system, let's look at what are some of the advantages for doing this. One of the advantages, as you can very clearly see in this example and in our library example, even though Ron only had a very small library, the warehouse was much cheaper. RAM is an expensive equipment to buy, but hard disk is very cheap memory. RAM, you must have maybe 16 GB or 32 GB. Every time you add 8 GBs on your MacBook, it adds like $250. But we can get easily 1 terabyte of memory in, let's say, $100 on Amazon. So as you can see, hard disk is very simple. And with this page table methodology, we are able to give virtual addresses for data which is not in our RAM. We are able to give virtual addresses which will get translated through our RAM, which will look for it in our main memory, bring it back to our RAM, and then service our request. So in this manner, just like Hunger Games 2 is a book, there will be millions of books. And just like 0x1000285 is an address, there will be millions of these addresses, more than what our RAM can handle, which our programs can access because it is accessing the disk memory. So first thing which we do is we extend our memory. The second thing which we do is that with this, we are able to make sure that two books are never put in wrong locations. So let's say that someone writes, like right now we are just servicing requests, but let's say someone is also going to be Ron is going to be putting books into our library, right? And someone who puts back books after they borrow their books, they are going to put it back into the library themselves sometimes. They cannot just put it randomly. It is going to be done according to the indexing of the page tables. That way, no two people are trying to clamp their both books in the same location. This might not make great sense with books, but it happens with programs where they try to write to the same memory address, and that can kind of corrupt the data in our memory. So that is not going to happen. So it protects the memory. It protects our memory, right? That is the second thing which happens. And the third thing which happens is that because we are indexing, right? Because we are indexing, what is going to happen is that in our page table level 2, our Hunger Games can be in some part of our memory. Our next thing can be somewhere else in memory, and we can use the space in between. Otherwise, what would have happened is, let's say we had one big RAM, someone would have put Hunger Games series over here, then he would have left 3 spaces over here, he would have put Zenobia series over here. Now he has a new series, and that series is called Quilt series, and this has 5 books. Now he has to put it sequentially because the way we are indexing our books is by we take our first location and then the offset. But he cannot put his 5 books over here because there is only 3 locations, and he cannot fragment it because that logic does not exist. He has to put it sequentially. So, but when we look at page tables, we can put 3 books over here and 2 books over here. So in that way, we can split up our memory without leaving any holes in it. So the third thing is we can work with defragmentation. Now the uses of virtual memory I have not explained really well with this anecdote, but I have explained the translations. I have explained how TLB lookups work. I have explained how TLB evictions work. We remove Zatar 5, we put back our hung series. And this gives you a very good basis for virtual memory, TLB, translations, multi-level page tables, which are some very complex, higher university level computer architecture and operating system concepts. So if you would like me to go into depth on the uses of virtual memory, on how these different virtual memory translation help computer systems, like how they extend memory, how they protect memory, how they avoid defragmentation, then please put it into the comments and I will make videos for that. Otherwise, I hope this has been a very great experience for you and you really do understand how virtual memories work in our computer systems and how they work intuitively. Thank you.